What is a nuclear power plant simulator? Introduction. Electricity is all around us. It makes our lamps shine, powers our computers, and keeps our cities alive. Yet we never actually see it. It is invisible. Behind this discrete energy lie complex, powerful, and sometimes mysterious facilities, nuclear power plants. But how does one learn to operate them? How can you train without ever putting the real plant at risk? The answer lies in a unique tool, the simulator. What is a simulator? A simulator is a full-scale replica of a nuclear power plant's control room, connected to digital models that calculate in real time what would happen in the actual installation. Every light, every button, every alarm responds exactly as it would in reality. The main models. One. The neutronic model. It simulates the chain reaction in the reactor core and the heat production inside the fuel elements. It shows how the control rods slow down fission and how the power level changes. It includes elements such as the reactor core, control rods, fuel, and moderator. A nuclear engine that can be sped up or slowed down. 2. The thermo-hydraulic model. It calculates how the heat from the core is transferred to the water, how the steam circulates, and how pressure and temperature evolve. Like a pressurized plumbing simulator, where every valve influences the whole system. It includes elements such as steam generators, pressurizer, and pumps. 3. The electrical model. It reproduces how part of the generated electricity is reinjected to supply the plant's own needs. It includes elements such as the alternator and breakers. 4. The control and instrumentation system. This is the nervous system that defines the operation of motorized equipment such as automation, regulation systems, and monitoring tools like sensors and alarms. The simulator reproduces all of this so that every indicator light and every alarm is realistic. 5. The imaging system. Screens display dynamic diagrams of the plant, showing its operating state with real-time data on temperature, pressure, flows, and valve positions. Operators can see, in real time, what is happening inside the virtual reactor. It includes diagrams and digital displays presented on screens. Interconnected models. These 5 parts are all interconnected. The simulator is complex. Each part communicates and interacts with the others. Notifications are exchanged between the different modeling files that make up the simulator. How is it developed? Before a simulator can be used for training, it must go through strict safety, quality, and performance tests. The development process brings together integration, verification, and validation, agreement on technical requirements, and the delivery of solutions that comply with regulations and contracts. It also involves managing design changes and documentation, providing expert technical input across projects, and sharing systems knowledge to support the development of engineers and their teams. The instructor station. The control tower. Next to the control room, there is always an instructor station. This is where trainers can launch scenarios, trigger failures such as pump breakdown, stuck valve, power loss, speed up time, or repeat a transient several times. In short, the instructor is the conductor who makes the simulation unpredictable. What's the purpose? The primary purpose of the simulators is to train new and existing reactor operators in the knowledge and skills necessary to safely and efficiently operate a nuclear power plant. Simulated scenarios replicate the exact conditions of the plant and are vital for gaining experience in situations that may never occur. In normal daily operations, simulation training is a cornerstone of nuclear safety culture, ensuring operators are prepared for all possible situations and can maintain safe, reliable operations at all times. Conclusion: the full-scope simulator is the bridge between the real and the virtual world, a space where operators can learn, make mistakes, correct themselves, and become more confident before taking charge of a real plant.